Welcome to Swam's online lecture series on the topic Database Management System. I am Muhammad Allah Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim University, Aligarh. I am pleased to have you join me. Today we will go through some important topics of database management system in detail, by which you will be able to understand the exploration of database management system in academics as well as in the field of information technology. In the next few minutes, we will discuss a schema mapping in data integration, a schema optimization techniques, and data dictionaries. In the previous session, we have discussed data model, data schemas, and instances, difference in database schema and database instances. Before proceeding with today's agenda, I would like to discuss some questions that I had given you in the last class. The first question was, what do you mean by the data model? Explain in brief. The answer is, data models are structures that represents how data is stored, accessed, and managed in a database system. They define the logical relationship and constraints between data elements, ensuring consistency and integrity. Essentially, data models serve a blueprint for organizing information, allowing for efficient storage, retrieval, and manipulation of data. Common types include relational model, hierarchical models, and network models. These models simplify complex data into a structured format, aiding in the development of databases that accurately reflect real-world scenarios. The second question was, what do you understand by database schema? Discuss all types of database schema. The answer is, a database schema is a plan detail how information is stored and related in a database. It includes various types like the physical schema, specifying data storage on devices, logical schema, outlining logical organization and relationships, and conceptual schema, offering a broad overview of the database content. Additionally, hierarchical schema arrange data in a tree-like structure. Network schema depict interconnected records, and relation schema organize data into tables with defined connections. These schemas serve as a blueprint for creating, managing, and understanding of databases, crucial for efficient data storage, retrieval, and manipulation in different systems. The third question was that what are the difference between database schema and database instance? The answer is, a database schema is a blueprint defining how data is organized and related, while database instance is a snapshot of the database at a specific moment, including its data. The schema is the design and the instance is the actual data present in database at a given time. The last question was, what do you understand by database instance? Discuss all types of database instance. The answer is, a database instance is a specific occurrence of a database at a particular moment, encompassing its data and operational data state. Types include a standalone instance for a single user access and shared instance for multiple users. Instances can be classified as active or passive based on their usage and accessibility. So the agenda of today's lecture is to discuss a schema mapping on data integration, next schema optimization techniques, next is schema macro services, and the last will be data dictionaries. So let me recall the topic, what is schema. Let us start with the backbone of our database world, schemas. A schema is like the blueprint of building, defining how data is organized and structured. It is the master plan that keeps everything in order. A schema is a fundamental concept that represents the overall logical structure or blueprint of a database. It serves as a framework for organizing and defining the relationship among the data elements, providing a structured and semantic approach to data storage and retrieval. A schema defines how data is stored into tables and relationships between these tables and the constraints that govern the integrity of the data. Schemas plays a vital role in the database design, offering a structure framework for database administrator and developer to model a real-world entities and their relationships. They facilitate data organization and efficient data retrieval. The use of schemas also allow for data independence, separating the way data is stored and structured from how it is presented to user, enabling changes to be made at one level without affecting other. Then we discuss about data schemas. A database schema is logical representation of data that shows how the data is in a database should be stored logically. It shows how the data is organized and the relationship between the tables. Database schema contains table, field, views, and relationship between different types of keys like primary and foreign keys. Database schema provides the organization of data and the relationship between the stored data. Database schema defines a set of guidelines that control the database, along with that it provides information about the way of accessing and modifying the data. So first we will discuss schema mapping and how it plays a pivotal role in achieving this integration seamlessly. Schema mapping is the process of aligning data schema from different sources to enable consistent and data exchange. It involves understanding the structure and semantics of source and target schema and defining mapping between them. So, schema mapping fundamentals, schema matching techniques, data transformation and reconciliation, challenges and solution. Let us start one by one. Schema mapping fundamentals. Understand the basic of schema mapping, where we align the structures of different databases or data sources to enable consistent schema matching techniques. Explore the techniques such as automated schema matching to identify correspondence between attributes in different schemas. We will discuss how this helps streamline the mapping process. Data transformation and reconciliation. Learn about the data transformation and reconciliation process in schema mapping. These are critical steps ensuring that data are from various sources These critical steps in ensuring that data from various resources, challenges and solution. Discuss common challenges in schema mapping, including handling semantic mismatches and coping with evolving data structures. Explore solutions and best practices to overcome these hurdles. Now, let us discuss the techniques for schema mapping. There are three types of schema mapping: manual mapping, second is automated mapping, third is hybrid mapping. Let us start one by one. Manual mapping. Analysts manually identify and define mappings based on their understanding of source and target schemas. This approach is labor intensive and prone to error but offers fine grained control. Automated mapping. Tools and algorithms are used to automatically infer mappings based on similarities in schema structures, data types, and semantics. While faster, this approach may lack precision and require human validation. The last is hybrid mapping. Combining manual and automated approaches to leverage the strength of combining manual and automated approaches to leverage the strengths of both methods, striking a balance between accuracy and efficiency. As databases grow in size and complexity, optimizing the schema become imperative for ensuring efficient data retrieval and overall system performance. Key concepts: indexing strategies. Understand the importance of indexes in schema optimization. Explore different indexing strategies and learn how they impact query performance. Query optimization. Delve into techniques for optimizing database queries. We will discuss query execution plan, statistics, and other factors that influence the efficiency of data retrieval. Denormalization and performance trade-off. Explore the concept of denormalization and its role in schema optimization. Understand the trade-off between normalized and denormalized schemas in terms of storage and query performance. Next is partitioning and sharding. Learn how partitioning and sharding contribute to a schema optimization, especially in distributed database environments. Understand how these techniques enhance scalability. Now we will explore how microservices architecture can be applied to database schema design to improve scalability, flexibility, and maintainability. Schema microservices are modular, independent components responsible for managing specific subsets of data and functionality within the larger database system. They encapsulate schema definitions, data access logic, and business rules, enabling decoupling and autonomy. More this, we have to understand the key concept of microservices. These could be service boundaries, data isolation, and loose coupling. Service boundaries. Define clear boundaries between schema microservices to enforce separation of concerns and minimize dependencies. Data isolation. Each microservice manages its own database schema, ensuring data isolation and preventing interface between services. Loose coupling. Schema microservices communicate through well-defined APIs, allowing independent development, deployment, and scaling. Now we will explore how microservices architecture can be applied to database schema design to improve scalability, flexibility, and maintainability. Schema microservices are modular, independent components responsible for managing a specific subsets of data and functionality within the larger database system. They encapsulate They encapsulate schema definition, data access logic, and business rules, enabling decoupling and autonomy. Data dictionary. Now imagine having a guide that tells you everything about your blueprint. That's where data dictionaries comes in. Our data dictionary is like a encyclopedia of our database, providing definitions, descriptions, and relationship between different elements. A data dictionary contains metadata, that is data about the database. The data dictionary is very important as it contains information such as what is in the database, who is allowed to access it, where is the database physically stored, etc. The user of the database normally do not interact with the data dictionary. It is only handled by the database administrator. The different types of data dictionary are active data dictionary and passive data dictionary. Let us start about active data dictionary. If the structure of database or its specifications change at any point of time, it should be reflected in the data dictionary. This is the responsibility of the database management system in which data dictionary resides. The data dictionary is automatically updated by the database management system when any change are made in the database. This is known as an active data dictionary as it is self-updating. The next is passive data dictionary. This is not a useful or easy to handle an active data dictionary. A passive data dictionary is maintained separately to the database whose content are stored in the data dictionary. That means that if the database is modified, the database dictionary is not automatically updated as in the case of active database dictionary. So, the passive data dictionary has to be manually updated to match the database. This needs careful handling or else the database and data dictionary are out of synchronous. Let us take one example. An implied database, the user schema might have details like name and roll number. Let us consider an example, an implied database. The user schema might have detail like names and roles. The system schema manages overall database functionalities. Sub-schema handle a specific like payroll, and the data dictionary provides detailed explanation of each element. In today's lecture, we discuss about the schema mapping in data integration, schema optimization techniques, schema microservices, and data dictionaries. Now, let's access your knowledge and track your progress with a few thought-provoking questions. Your answer will not only reinforce your understanding but also serve as a valuable gauge of your grasp on the crucial topics discussed today. Today's question to test your knowledge are: what is the purpose of logical schema? What do you mean by a schema mapping in data integration? The next question is: what do you mean by a schema optimization techniques? What do you mean by a schema macro services? The last is: what is the purpose of data dictionary? In our exploration today, we have navigated the intricate world of schema mapping in data integration, schema optimization techniques, schema macro services, and data dictionaries. I have tried to cover all the aspects of the above mentioned topics in detail as possible. I hope you enjoyed this exploration. I will look forward to you in the next lecture. Till then, keep your study and health well.